Hey everybody, how are you doing? Welcome to this webinar hosted very kindly by the good folks at Particular Software. My name's Elton, I'm a Microsoft MVP and Pluralsight author, and I've been doing integration type work for a very long time, 15 years, something like that. I'm glad to say that here with me today I've got Mauro Saventi, who is a solution architect at Particular. I think I've just muted him. You say hello, Mauro?
Yes, welcome everybody, and thank you for joining us, Elton, for this webinar. And so let's get started.
Absolutely, yes. So we're going to be covering today how you handle failure scenarios. So we'll start by looking at different types of failure you're going to encounter in distributed systems or any type of system where you've got some sort of connection going on where something that you expect to happen might not happen as you want it to. We've got a demo application that's very simple that's going to evolve throughout the presentation. So we'll start off with no error handling, and we'll move through a series of approaches to the end where we're doing error handling through messaging, and we'll see the options that gives us and the richness of how we can approach that once we put a message queue into the middle. So we start with synchronous failure handling, we'll move on to asynchronous failure handling, and we'll recap at the end with a look at how our messaging architecture enables us to do more when we encounter an error than we could if we were just using synchronous communication. So the two types of failures we're going to be looking at mainly are transient failures and permanent failures. So a transient failure is when you've got a connection between two systems and for some reason the connection doesn't happen correctly. So you see it often in distributed architectures. The cloud architectures make it more obvious because there tends to be a greater latency between the two systems that you're connecting, but it could happen even locally. So as an example, if you've got a database, when you make a database call, there's nothing to say that the database will actually react in a timely fashion. There could be a network timeout because the network is slow, or there could be lots of people using the database at the same time, so the connection pool gets exhausted. Either of those means your connection is going to fail. Similarly, if it was a REST API that your component is talking to, you could get a connection timeout because of the network, or the API itself could be overloaded and you'll get a 503 response saying service unavailable, and you need to take corrective action because obviously you're expecting either in the database example to get a query response back, or in the REST API you're expecting a 200 response with a JSON payload. So you need to be you're in a failure scenario, you need to be able to deal with it. With transient failures, the overriding feature of them is that they are temporary. You can expect them to be temporary. You should retry them. How you retry them, whether you leave a pause and then retry, how many times you retry, are policies that you need to evolve as you're building your failure handling. But the key thing for a transient failure is you can retry it. You should retry it, and ideally it will succeed within the policy of retries that you've set up. With permanent failures, similar system, I've got one component talking to another component, but there's a serious failure has happened. Something has happened that can't be corrected by retrying it. So the contract between the consumer and the provider has changed. So it doesn't matter how many times I try and retry my request, I'm never going to get a successful response. Or the authorization has been changed, so I'm no longer allowed to make the call that I was trying to make before. So examples of that again for a database, if you're calling a stored procedure and the parameters have changed, someone's introduced a new parameter and your component hasn't updated to reflect that, that call's never going to work. It's always going to fail. If you're using a service account to connect to the database and the permission's been revoked, your user no longer has access, you're never going to be able to get in there without some sort of external change to fix it. In the REST world, the example would be a bad request. So if the contract between the API and the consumer has changed, then you're going to get a 400 response back that you need to do something with. Or if you're, again, similar scenario, if you're consuming a commercial service, you haven't paid your bill, then your account might be deactivated, and you'll get a 401 or maybe a 403. In any of those cases, it's permanent. You can't just retry it and hope that it's going to be okay. Something external to your system has to come in and fix the situation so it can be repaired. So we're going to be using a simple... Oh, yes.
Oh, yeah, sorry. May I ask a question related to the failure types that you just described? That is, do you think it's worth to add to the mix what we can call business failures, such as, for example, let's say that we have a request that is asking for to create a new user given an email address, and that email address already exists in the system. So basically, from technically speaking, the request is well formed and can be handled, but is violating some business rules. So is it worth to say that we have a third type of failure that is a business failure? How do you think it should be handled, if it should?
Yeah, that's a very useful classification. So the business failure is something which you obviously are going to see in the life of your system, but it's not something that the system itself can be expected to repair. So so what we're talking about effectively is violation of validation rules. So something's coming in that's not in a request doesn't have a valid state, or the request would lead, if it was fulfilled, it would lead the system to be in an invalid state at the end of it. Those are things that the system itself, I don't think, should be able to repair those. So unlike a transient failure where the system can be aware of what's going to happen and it can react to it and it can try and heal itself, or with a permanent failure where the system at the very least can capture the request that it was trying to process and then attempt to replay it later on, with a business failure, the request itself is not valid, so the system cannot repair it. It would need to go back to the original requester and say, this isn't right. This is where you get your error message on the screen saying the email address has already been used, or it needs to go back to your business partner and say this is something we can't fix. So what we're talking about here in this webinar is things that the system itself can try and deal with, and a validation failure, it needs to be handled, I think, at the front end. So when the request comes in and you've got someone listening for a response, the response you can give them is this is not valid. So in short, I'm not going to be dealing with business failures in the rest of the webinar. So so if I carry on, then we've got a very simple web application. All the code for this is going to be on GitHub as soon as the presentation's done, and we'll be sending out a recording of what we've been through today. So it's a very simple web app. It puts you in a position where you've just bought something from a web store and you're about to get a confirmation of your order, and you can choose how you want to get your confirmation, by email, text message, or direct message on Twitter. Each of those options makes a request to a different API, and in my little demo system they're all stubs and they all respond in a predictable way. So if you select email, it goes to an API which always returns you a 200 response, so that's the happy path, that's fine, we know what we can do with that. If you select text message, it goes to an API which is not reliable, so 30% of the time you'll get a 200, and that's okay, but the rest of the time you'll get a 503 saying that it can't service your request. So this kind of mimics the situation where you're calling an API that's severely overloaded, so the majority of requests can't get through, but some do. So that's why this falls into a transient failure that is worth retrying, because actually if we try it a couple more times, we'll fit into that 30% and we'll get the positive response. And the final option, the Twitter option, goes to an API which always returns a 400. So that's a permanent failure. There's nothing much we can do about that without making an external change to our system that we need to fix. Okay. So there are 3 versions of the app that I'm going to walk through. The first one is the simplest, inside the web app, which is just ASP.NET MVC. It makes, when you submit the form, it makes a direct call to the relevant API. So it just calls the REST API, there's no error handling, and whatever the result is gets thrown on the screen. I'm using the old .NET Web client rather than the new HTTP client for the specific reason that if it gets a response from a web call which is not a 200 OK, it throws an exception, which is what I want. I want us to see what happens when we get that exception. Okay, and if I switch to my code, this is how the little demo app looks. So I've got versions 1, 2, and 3, which all look exactly the same, but they behave slightly differently in terms of their error handling. Version 1, there is no error handling. So when I click on my email option, I get a confirmation because that one always returns 200. When I click on my Twitter option, that always returns a 400. So I get a bad request response no matter how many times I try that. And with my unreliable option, the SMS message, sometimes I'm going to get a positive response, so that was okay. If I try it again, then I will, sooner or later I'll get an error. So there I are. I've got a 503 server unavailable. So that's just randomly responding either with a 200 or a 503 in terms of the ratio of about 3 successes to every 10 requests. Okay, so the code for that is fairly naughty. So I've got my version 1 send is when you post that form, it comes into here. It works out whether it's the type of fulfillment. Is it going to be email, text message, or Twitter message? And then it gets an API client from the factory. This is all very basic stuff, so actually these API clients all look the same. They all make a simple call to using a web client to a known API, known URL, which is configured differently for each type of fulfillment. So email goes to one API, SMS to another. They all look very similar, and they all do the same thing. Inside the API clients, there's no error handling. So the idea of this is that the consumer of a fulfillment client is going to do its own error handling. So these guys don't try and don't work within a try-catch block. They don't throw their own exceptions. They just let everything bubble up to the caller, which is why we see in our fulfillment controller for version 1, when we call that send, there's no error handling around there. There's no try-catch. So when we do hit an error, when we hit either the 400 response or the 503 response, that goes directly to the user. They see that, and that's the response they see in their page. So that's just a kind of introduction to show you that this is very, very simple. We've got a couple of APIs that behave in an expected way, and we're going to add some error handling to this app to make sure we can deal with those in an effective way and to see what our options are. Okay, so that was the version 1 app. That's the kind of baseline. There's no error handling in there. If we get a failure in the system, the user sees the failure, and it doesn't matter whether it's a transient or a permanent failure. As soon as it hits an error, that's it. The error gets shown to the user, and then the user has to decide what to do next. So if we're going to add some error handling to our system, we need to decide what we do in terms of transient and permanent failures when we hit an error condition. And here's a kind of simple flow diagram of an easy way to approach that. So we start off at the top, we've hit a failure, we need to work out whether it's a transient or a permanent failure, so we know whether to retry it or whether to audit that we've had a failure in some way that we can do something useful with that information later on. If it's audit, that's fine, we stop. If we retry it, then potentially we're going to hit another failure. So if it's okay, we come to the end again. If it's not okay, we're back to the top of the scenario. We need to decide whether it's the same type of transient failure or whether it's a new permanent failure, and we need to react accordingly. There are a couple of things that are key about that flow diagram. So firstly, how do you work out the type of the error? How do you work out if it's a transient or a permanent error? The examples I've shown are reasonably clear cut. So if you get a 503, by nature that means service unavailable and the API is overloaded. It's worth retrying. If you get a 500 error from an API, that doesn't necessarily mean that it's a permanent failure, because it could be that the API is still overloaded, but in a different way. The API isn't responding correctly with the correct type of message. So in some scenarios, you may want to retry a 500 for a particular API, but for another API, you might only retry 503s. So working out how the type of the failure is actually not trivial. The other option that I show with the database, something like SQL Server will give you a type of failure code, and you can decide from that whether it's something that's worth retrying. But you're potentially going to end up with a great big switch block that says, if it's code 123, then I can retry it, otherwise I can't. And how do you keep that up to date as new codes emerge and you encounter new types of scenario? Once you've worked out successfully whether it's a transient or a permanent, how do you then retry it? If you're hitting an API that's giving you a 503, it's already working hard. You don't want to retry it immediately and then retry it 10 times, because you're just making the situation worse. So potentially you want the option to have a pause in there, and maybe something more complex like an exponential backoff that says, I've hit a 503, I'm going to wait a couple of seconds, try again. If I get another 503, I'm going to wait 10 seconds and then try again. If I get another 503, so it gets longer and longer. It gives yourself more time to get past the burst of load that the API is not coping with, and get back to a point where it can handle your request successfully without adding to the amount of load that it's trying to deal with. And then on the flip side, if it's a permanent failure, What are you going to do with the information that you've got? At the time of the failure, you know all the details about the request, you know what's gone wrong, and you can store that in some sort of meaningful way. But if you're going to store all the details of an API request or a database request, how are you going to store them in a way that makes it useful later on when potentially the problem's been fixed and you could potentially replay that process? You'd have to store all the information you need at the time of failure to be able to replay it later on. So a couple of things there to bear in mind as we look at the next evolution of the app, which is adding a very simple try-catch block around the synchronous processing. So we've still got a synchronous call to the APIs coming from the web layer. We've got a very simple failure handling process in there where we wrap up our API call in a try-catch block, and in the catch block we go through that flowchart. We try and work out if it's a transient or a permanent failure. If it's transient, we'll retry it in a very simple way, and if it's permanent, we'll just log that we had a failure. And there are limitations in what we can do there because this is happening in the front end. So when the web server is dealing with someone's request, they're sat at the end of a screen somewhere waiting for this page to load, while in the back end the web server is calling an API and waiting to get the response. So let's have a look at how it looks. So our version 2 of the app, let's go back here, looks exactly the same, apart from it says v2, and it behaves in a similar way for the completion scenario. It just goes through to say already complete, coming via email. If you choose Twitter, now you still get the order complete. Now we know that that API has responded with a 400, so the error handling that's happening here is catching the error, but it's giving the user a false impression of what's actually happened. The user thinks it's been successful, but actually we know it hasn't. And then the worst case scenario where it may have been successful, the user still sees the success message, and us as the administrator, we don't know whether that succeeded or not. So it's better from the user's point of view. They see a friendly message no matter what the underlying call has succeeded or not, but it's potentially not great from an administration point of view. So the code for version 2 is in this block here. Fundamentally it's the same. We get the fulfillment type, which tells us what type of API to use. We go to the same factory and get the same API client, and we make the same call, but we wrap it up in a try-catch. So the catch is where it starts getting interesting. We're catching a specific type of exception because we're only interested in web exceptions, because there's only those that we can use to work out whether it's a transient or a permanent failure. So we have to cast our response to a web response and then get the status code out. And it's that status code that we'll use to say, is this something that's worth retrying, or is it something that I have to just stop and move on? So if it's a 503, which is service unavailable, we retry. But this is really basic. It's just saying, right, let's try again, and let's hope for better luck this time. It's not doing anything complex like saying, okay, let's pause for a few seconds and then try. And the reason it's not doing that is because it can't. I've got a user sat on the other end of this process waiting to see a screen. So I can't have a series of exponential backoffs. I can't keep adding time and hoping that the API will clear its backlog and wait a few more seconds and then try again. I can't retry several times because I've got a user at the end of this process. So the error handling here is really in the wrong place to give us the options to handle this in a really in a smart way and not overload the service that we're trying to call into. If it's a bad request, if it's a 400 error, which is what we get from our Twitter API, our stub API, then it doesn't do anything in this case. So I would log something here, but then there's another question of what do I log and how do I store it in a way that's useful, that I can actually take that request, find it later on, and say this is something that I'm ready to process again now because I've fixed whatever the problem was. So that's the kind of manifestation of that flowchart that we've seen, and there are a few problems with it. From the user's point of view, it looks better, but from the administrator's point of view, we're hiding some of the failures that we've got. We're potentially adding more load to an already overloaded service in one scenario, and in the other scenario, we've got a question here about how we can capture enough information to make the fact that we know at this point that it failed and we know what failed. How do we capture that information in a useful way? So the version 2, it's a kind of, it's better in that the user never sees an exception message. It's better from our point of view because in the case of transient failures, some more of them now will succeed. So whereas previously every time we hit an error, that would be it. It wouldn't try again. Now we're at least trying one more time, but it's very limited in what it's doing and what it can do. So I can't keep retrying the same message because I've got compute power tied up in my front end to serve this web page, and I don't want to use that compute power to keep on looping through trying to call a service which may take 30 seconds to respond. So my retry options are limited if it's a transient failure, and if it's a permanent failure, my audit process is necessarily basic because I've got all the information, but what do I want to do with it? I could serialize that whole request in some sort of JSON payload and store it somewhere, and then potentially I could replay that later on, but that would all be a lot of custom work, and I'd have to do that for all my API calls. And that gets to the point of what do I do even if I have captured all that information? So in a synchronous approach where if I was capturing a failure like a 400 request, I was recording everything about it, then at some point the problem will have been fixed. So if it was a business problem like the bill hadn't been paid, the bill gets paid, the service is available to us again, we can start replaying all those requests if we've got them somewhere that enables us to replay them. So if we captured all the detail, if we potentially captured all the requests in the correct order, because order may be important for our system, if we are able to store them somewhere and pull them all out again, then potentially we can replay all those. But all those steps of recording the request, keeping the order, keeping it somewhere permanent, and pulling them all out again, they're all custom if we're going to build that into a synchronous system. And what we're effectively building is a message queue, which is what version 3 of the app is going to show us the alternative way of approaching this. So with version 3, we decouple the sending of the API request from the web front end. So now when you submit your form, it sends a message to a queue, and I'm using 0MQ here for the message queue. And then on the other end of that, there's a message handler that pulls those messages out, and it makes the API calls. So the user is going to see a response message on the screen telling that it's been processed, while the handler is still in the back end doing the actual processing. And the reason for using 0MQ, in case you're interested, is the previous webinar that we did, we used MSMQ. I'm trying to give a different flavor for different types of message queue. The actual transport isn't really relevant, so I could use anything to be that message queue in the middle, as long as it gives me the key criteria of having a queue that will store messages in the order that they arrive and letting me pull them out from one or more handlers. Okay, so let's have a look at how version 3 looks. So with version 3, same front end with a 3 at the beginning, and I've also got a back-end process now. So it's the classic console app that you always get when you're doing any messaging demo that says it's listening. So this is the handler that's going to pick up the message that says, I want you to send some fulfillment request out to one of my APIs. So when I send out for an email confirmation, then on the left-hand side in my handler, we see that it's received a message, which is a send fulfillment command. That message has got an ID. It says it's handled it, and it's logged the fact that it successfully sent a fulfillment of type email. If I go to version 3 and send a Twitter message, then I get a lot more stuff coming through. So I get my message received that it's a send fulfillment command, and I've got a message ID starting with 85. I handle the message, and then I've got a fulfillment failed log entry in there. And then I get another received message, but it's the same message ID. So what I'm finding is that the message fails, so I send it back into the queue, and I try again. And this count is telling me how many times it's handled that same message. It's already handled it once, it tries again, it fails again, so it sends it back into the queue. And this time, when it fails again, I receive it for the 3rd time, and I say I'm not going to handle it again. It's already failed 3 times. I don't know what type of error it is, but I'm not going to proceed because I think this is something permanent. So I keep trying, I keep failing, I'm not going to do it again. And for the text message, which is the unreliable API that may give me a 200, may give me a 503, I'm going to see In this case, it failed 3 times. So even though the user still sees that confirmation message on the screen, I've got a failure behind the scenes which looks permanent. So even though it's a 503, I've tried a few times and I haven't successfully got a response. But if I try again, this time it works fine. So it handles it first time round there. So that's so it's going to retry it within a policy of that I've already specified in the code. So let's have a look at the code for that. So with version 3, when I post my request to my controller, there's a little bit more going on. So first of all, I try and work out the fulfillment type, whether it's going email, Twitter, or SMS. And then I build up a message that I'm going to send to the queue. Now I'm using ZeroMQ. It's lets me build up a multi-part message. So I've got a header telling me what type of message this is, because in any real-world system you potentially have different types of messages in different types of queues, in different queues rather, that would give you the option to spread your handlers around. So this tells my handler what type of message it is. And then the body, which contains everything I need to know about this request, which is the fulfillment type and the address that it's going to send to, which is just hard-coded here to make it clear that that's not very important. And then this is a specific detail for ZeroMQ. So this would be different depending on your transport, but the principle of it is all the same. I'm building up a message which contains my body and my header, and I'm getting ready to send it. And with ZeroMQ, you send it using it uses a terminology adapted from socket processing and the low-level networking. So I open up a context for my ZeroMQ queue, I connect to the socket, and then I send my message. And that's it as far as the web front end is concerned. That piece of work is done. It goes back to responding to the user, and it doesn't know or care what happens at the other end of the queue. So in the other end, I've got my message handler console app, and some of this code will look familiar from the ZeroMQ stuff that we've just seen. So I've got my context, which is how I set up a connection that's going to use ZeroMQ. I create my socket, and this is a pull socket. So ZeroMQ uses slightly different terminology from the other queues. Fire and forget message, where the sender just sends a message in and doesn't wait for a response. In the ZeroMQ world, we call that push and pull. So this socket is listening for messages that are coming in from my web front end, and then it binds to the address, which means it's sat there. It's listening for messages to come in. The little loop here is going to keep on listening for messages, and every time I get one, the first thing I do is pull out the header, which is the first part of the message, and deserialize it into my own defined header object. And that's where I get my line saying I've received a message with a specific ID, which is unique for each message. I've got this type of body, which is what tells us it's a submit fulfillment command, and the number of times that I've already seen that message. So this handler will say that as part of the header, I've got a count to say how many times I've seen this particular message. So if the handle count is less than 3, then I haven't seen this message a sufficient number of times for me to be concerned that there's something permanently wrong about it. So I'm going to handle it again. So I write my log saying I'm going to handle the message, and then I do the handle. And the handle is where we've got the same code that we had previously synchronously inside the Web API controller, inside the MVC controller, where I'm getting out my my fulfillment client, API client, and I make the call. But in this case, I'm still doing my try and catch, but I'm not concerned about whether it's a transient or a permanent failure. Because what I'm going to do is if I've got a failure, any type of failure, I'm not looking for something specific here. I'm going to log the fact that I had a failure, and then I'm going to add it back into the queue. I'm going to send that message back to the queue. So what I do is I find the exact same queue address, I increment the number of times that the message has been handled, and I also capture the last exception message that I saw. And then I build up a message which contains the new header, which has got the incremented handle count, and the original body, which has got all the request data that I need to send to handle that message, and then I send it back to the same queue. Which is why when we had the 400 message, we saw that the same message got handled 3 times, because it went back to the top of the queue. No other messages got dealt with in between, so we just saw those successive logs saying that the message was being handled, the same message being seen over and over again. By the time I've already handled it 3 times, if it comes back into the handle process, it says I've already seen it too many times for anything good to happen here. So I'm going to log my message, and then I'm going to do something else with it. And this is the auditing step. there's a to-do in there, because typically what you would do at this stage is I would send that to a different queue which has got a different handler listening to it, or potentially just a trigger to say to someone to manually intervene, have a look at what's going on here, because something's happened that looks like a permanent failure, which will need something to happen external to the system for us to deal with. So there's a little bit more going on. There's another component, which is the message handler, and in this case it's not a physical component, but the message queue also exists there. But that gives us a few more options about how we deal with this nicely. This is still a very simplistic way of dealing with it. We're not doing any back-off policies. We're not doing any exponential back-off or anything like that, but we've got the option to do that now. Because this is running in a separate process, potentially on a separate machine or any one of a number of machines, because the handlers could be distributed, then the client is not waiting. I'm not using up front-end resource to keep retrying, so I could do more intelligent retrying. I could wait for a few seconds and then try the API again, or I could wait for a minute or even longer, or I could push it to another queue and have that queue being polled less frequently. So because I've decoupled the error handling from the front-end processing, then I've got a lot more options, a lot more freedom to intelligently try and deal with that error. Okay, so that's just a brief recap of what we've gained there by putting the message queue in the middle and putting the failure handling inside the handler. The integration between our system and the external systems is happening offline, so users aren't waiting for a response while we talk to our API. That's not always an option, but for scenarios like this where effectively we're dealing with a command, then we can completely decouple it and leave the UI to its own thing while we deal with the messages offline. It gives us that wider scope for retrying when we do hit a failure. So we don't need to worry about the fact that I've got a user sat on the end of a screen who's going to navigate away to some other provider. If I take more than 5 seconds to show a response, I can keep adding that exponential backoff. I can keep giving whatever it is that I'm calling into a chance to mend itself before I keep retrying. And it gives me the replay option. So my auditing option, which was a bit difficult to deal with in the synchronous approach, is now a lot simpler. And it's a lot simpler because of all the components that build up the standard messaging architecture. So in my message, and I had a multi-part message in the example, I've got everything that I need to fulfill the request. And necessarily I have, because the message is all there is. We capture all that in a single message and send it to the queue. Because we're decoupled, it has to have all the information that we need to process the fulfillment request. So I've got all the request data, in this case very simple, just the fulfillment type and the user's address. But I can also put my processing data in there. So in my header for the message, I put in whatever data is interesting to me. So I'm recording the number of counts that I've handled this same message. I'm also recording the last failure message that I got, so I can put that somewhere useful. But I can put whatever I need to in there. The queue is an ordered store, so I'm dealing with messages as they come in, and I'm using something very straightforward in ZeroMQ, but for more advanced queues, you often have options for transactional processing, so I can deal with one or more messages in a single transaction and commit or roll it all back, or I can have acknowledgements that I've dealt with a message. So I could have the option to do my failure handling at that level, at the queue level, so the handler could try and process a message. If it can process it, it doesn't acknowledge that the message has been dealt with, and then another handler could pick that up later on. So the queue itself gives us options to deal with failures more gracefully. And then the handler is a key part for decoupling our error handling from our front-end processing. We're not using compute power to keep retrying situations where I may be having a transient failure. And the other thing about the handler, which is a core part of this, as well as being scaled up, if I've got lots of messages that I need to replay, it can also be scaled down to nothing, so I could have no handlers. And that's a great option if I'm dealing with an external API that's maxed out, or there's a problem with authorization. I can just stop the handler altogether. And that means all the messages are getting backed up in my queue. That's fine. That's what the queue's for. I'm not hammering an API that's already overloaded, or I'm not pointlessly trying to call an API that's always going to tell me that I'm not authorized to use it. So all those messages back up in the queue, and as soon as I'm ready to retry them, either because I know that the overloaded API is working again, or because I know that the business problem, which meant that my requests weren't being dealt with, hasn't now been fixed, I can just replay all those messages. The mechanism to do that is the queue and the handler, which I already have in place. So I'm not building a whole load of extra stuff to do that. It's the standard set of processing. Okay, so this is it's quite a focused webinar about specific types of failure that are often overlooked. So you often tend to assume that if I make a database call, I'll get a response. If I make an API call, I'll get a 200 response and I can start processing the data that I get back. In a distributed system, and especially in a cloud level distribution, then you need to expect failure. You need to code for failure in your solution, and you need to handle failure in the right place. So the front end, whether it's your web front end or your API, is not necessarily the place to be trying to deal with transient failures by retrying them with a back-off policy, which potentially means your consumer, whether it's a human or an API client, is sat waiting for you to send back a response. So not only does the user suffer if you're trying to deal with failure in your front-end processing, but it also damages your ability to be able to deal with other requests in a performant way. You're using up your CPU cycles, constantly retrying something, when those CPU cycles could be being used to deal with new requests coming in from new clients. If you decouple that component, if you decouple the thing that's going to make the external call, then the handler has more options. So we've seen that you can keep retrying it, and you're now separated from the end user. So you've got more time. You can use a more intelligent retry policy. Your messages are persisted in a queue, whether the queue is on disk, whether they're just sat in the queue waiting to be pulled out. So they're sat there so they can be replayed. They can be moved to another queue if there's a sufficient number of errors, and that can trigger a manual process to look at them. So it's a tightly focused webinar where we've been looking at those two types of failure and how we deal with the fact that we've got a transient failure that can be retried and might succeed, or we've got a permanent failure where we need to audit what's happened in a way that allows us to replay it later on so that our system can recover itself. And ideally, you will have the right level of failure handling, which will allow you to heal scenarios where a service you're using gets overloaded, because you can scale back the amount of calls you're making and then retry them later on. And if there's a permanent failure, then you can go away and fix that in whatever way you need to fix it, whether it's a code change and a new deployment of your handlers, and then when you fire them all up again, all those messages get replayed and they all work successfully. So by introducing a message queue and decoupling your handler from your front-end process, you're able to deal with those failures in a much more sophisticated way. So we've left quite a bit of time for questions. So Mara, I don't know if you've been keeping an eye on the questions that are coming in.
Well, first of all, thank you. And while we're waiting for some questions to come in, I'd like to add a couple of comments for what you just shown us. That was amazing. That I highlighted a couple of keywords while you were speaking. One is auditing and the other one is persistence. Mm-hmm. So it's obvious that we need to design with failure in mind, but there are a couple of more key concepts are that once we have failed more than once and we decided to back off that message, we need to find a way to store that message in a single place where we can handle it later in time, maybe from the ops perspective or whatever process we'd like to put in place, but we do not want to leave that message in the input queue of the handler. Otherwise, we'll load the queue and we'll overload the handler itself, because no more messages can be handled. And at the same time, it's very important that when we move from a synchronous architecture, so from a synchronous communication style to a message-based one, it's really important to have a persistent queue, or to to deal with persistent messages in order to be sure that we are not going to lose any message. Otherwise, we end up with a corrupted system from the data perspective, because if we lose something in the middle, we don't know what the state of the system is at that point.
Absolutely, yes, and so the even if you're using something a transient queue like 0MQ, so with 0MQ, which I'm using just for simplicity for the demo, the queue doesn't actually, it's not persistent, it's held in memory. But if you were having a policy where you said we're going to try the same message X number of times and then we're going to move it somewhere to be looked at and dealt with, then you need that error queue to be persistent. So you would need to have, so at that point the transport does become important, because as a minimum you need to be able to have a persistent storage for messages that have failed other processing. And that could be a combination of different transports. So you could use 0MQ for its high performance, and then say when we've hit an error, then we need to use something persistent like MSMQ or WebSphere or whatever it is that you're using that's going to give you the reliability you need to say here's a message that we can retry it later. And the retry part and the intervention part is an important one too. Because we're capturing failures, we can then interrogate the data about those failures, and we can start building up a knowledge base of the kind of errors that we're seeing and the kind of resolution that we need to put together. I worked in an investment bank putting together a system where we were auditing trades that went through, and we were doing something very similar to this. We had it's significantly more complicated than this, but errors were being put into a queue, and there was a custom-built front end that looked at that queue and told people the type of errors that we were dealing with, and allowed people to replay messages once they'd fixed something. So in some cases we had a third-party API that had some additional data about people involved in a trade, and if we couldn't find a person involved in a trade, we couldn't report that trade had happened. So at part of the way through the workflow, we had to stop. The message that was being dealt with went to the error queue, and then people who were monitoring that queue from an administration level could see there are 200 messages queued up because we haven't got information about a particular person, and then that triggers a very well-defined business process that says go to the third-party system, add the information that we need, tell the IT guys that those messages are okay now, and literally all they do is select the messages and click replay. And then we kick off the workflow from the exact point where it stopped, and it all works successfully again. And being able to, obviously, you need to have your persistent messages, but having them somewhere where you can actually look at the sort of errors you're getting and build up that knowledge base of how they get dealt with is really useful for the business, not just from an IT point of view, for people to have an insight of what's going wrong repeatedly, how they can make sure that doesn't happen in the future. It makes that system a lot more valuable.
Okay, there's a question from Doug that is, how do you deal with poison messages? And can you, I'll add a follow-up, can you explain what poison messages are?
So yeah, very good. So it's something that you only get with an asynchronous messaging approach. You don't see that with synchronous processing. A poison message is you receive a message, and something about that message means that it can't ever be processed. Perhaps it's got the wrong sort of serialization. It's an XML message that's coming by mistake to something that's expecting JSON, and it can't deal with it. So no matter how many times you try and process that message, it's never going to go through. Now, if you've got a really simple retry policy that just says, like we saw in my demo, I've got a message, it doesn't process, I'm going to put it into the same queue at the back, that could potentially block the whole queue. So I could find that this message is failing, it goes to the back of a queue, more messages come in, but this message keeps being dealt with, it keeps being processed, or I've got a sufficient number of interleaved poison messages in there that the whole queue might back up. So what it means is that the message is bad, it can never successfully be processed, but the message handler keeps trying to process it. So that's why we have a simple way of dealing with that, is to keep that count attached to the message to say have you been seen before? That count, that increment of how many times it's been handled can't live in a message handler, because a different handler on a different machine could have that. That state needs to flow alongside the message. So that's why almost all the message queues have the notion of either a header or a multi-part message where you can put your own header in. And if they don't, then you can write your own envelope schema and put your message inside that. And that processing state needs to flow with the message, so no matter what handler picks it up now, it can say, this message it was first received 2 hours ago, it's been tried to be processed 100 times, I'm not going to process this, something's wrong, I'm going to put it into an error queue. And you can do intelligent stuff even around the error queue. So you can be looking at that last type of exception that was caught for the message and have a specific queue that is for serialization failures. Because you might, by looking at that queue, you might see that all those serialization failures are coming from the same client. And then your resolution process is to talk to the client, get them to fix up their schema, and then potentially you could potentially extract those messages, go through a process to fix them up, and then replay them.
Okay, there's a few questions that I grouped together, and hope the attendees don't mind, that ask how would you deal with communicating back to the UI that something went wrong, that something went well, that something succeeded, or that something is waiting for something else to happen?
Good question. It gets a bit trickier, which is why I deliberately didn't do it in the demo. It depends what your front end is. So almost always there's a limit to what you can expect people to wait. So if it's and that limit will change depending on the scenario. So if I've just been through my web store and I've just put in my credit card details and clicked pay, then my expectation of how long it will take to get a response and my willingness to sit and wait for a response is significantly higher than when I've just browsed to the home page and I'm waiting for it to load. So in that scenario, I might have a policy that said if I can't get hold of the payment server, then my window to retry is maybe 30 seconds, maybe more, because I know, or I can be confident that the user has invested enough in that journey to stop and wait, and you know they know that there are various levels of communication happening when you do a payment. So I can potentially get away with a few seconds there, and having a retry policy for that situation, which will keep the user waiting at the end, and then show them exactly what has happened. In different parts of the process, then it kind of depends what feedback you need. So if you're doing something offline anyway, if you're going to be sending an email, if you're going to be sending a text message or a Twitter direct message, then you don't necessarily need to keep the client hanging on until you know whether that's worked or not. So you can be saying, you can give them a message that's sufficiently ambiguous to say we've submitted your request, you'll be getting your email in due course, and then your retry policy, if for whatever reason you can't push out that email, has got a lot more lifespan. You can try a lot harder for a lot longer to get that through because there isn't someone sat at the end. And it depends how you're building your UI. If you've got, if it's something where, if it's a business app where the user sat there in front of the same app all day, then potentially you're going to have a task pane on the somewhere on there to showing them what's happening. And then you would have two-way messaging there to say the thing that you tried an hour ago, it's now succeeded, and potentially you might include information in there about why it took so long if it's something that if that's something that's useful in your scenario. But it would depend on whether your UI is long-lived, so whether the user is going to sit there long enough for you to push information back to them, and whether the user themselves are prepared to sit and wait for something that's going to garner them a response. And that depends on the situation. So in some cases, your user's not going to wait more than a few seconds, so if you're loading up a special offers page, then that's a query type of process anyway. So that would be something that's potentially not worth retrying, because if you're trying to reach your database to load up a screen, and after 5 seconds you don't get a response, well, there's not too much point in backing off for 15 seconds and trying again, because the user's long gone. They're not going to sit there waiting. So you tend to have different policies for different scenarios, and unfortunately you need to have a reasonable understanding of what you're going to achieve, what you think your user will put up with, and how you can communicate back to them. So, is it something where they're going to sit and wait for an immediate response, and if so, and it has to succeed, or they have to know that it hasn't succeeded, then your policy has to be limited to what you think their willingness to wait is going to be.
Yes, there's a question from Paul. I hope my pronunciation is correct. That along the lines with the error queue, basically, it's saying that it's more a confirmation that whenever we failed to process the message multiple times, we're basically moving the message to some sort of a dead letter queue where something else can happen. If I may answer to the question is yes, basically yes, the error queue is what we called the error queue is a dead letter queue where failing messages will end up after several attempts or a different policy based on the type of failure. One important thing that is related to why we call it an error queue instead of a dead letter queue, and correct me, Elton, if I'm wrong, is that a dead letter queue is a concept belonging to transports. For example, MSMQ has this concept of transactional and non-transactional dead letter queue, and dealing with the transport is not that easy from the application perspective because most of the time requires different privileges, the admin privileges on the machine, and we do not really want to install application with administrative privileges on servers, especially if they're exposed to the web.
Absolutely, and to follow on from that, so some of those dead letter queues are specific to the system. So with WebSphere, the dead letter queue is specifically to capture messages that were never handled, that were never pulled off a queue within a certain amount of time. So I can send a message in saying I want this to be handled within 30 seconds, and if nothing pulls it off the queue, then the framework itself will move it to a dead letter queue. So it's important to keep that distinction that an error queue is something that belongs to our solution that we create and we send messages to, and the dead letter queue potentially belongs to the framework. So you might not be able to use it yourself, and often you're going to have both. So you'll have a dead letter queue that is provided by MSMQ or WebSphere, and then you'll have your own error queue or multiple error queues to deal with things that are happening inside your own solution.
Okay. There's another question that is related to how to correlate back to the user, that is basically asking how would you deal with failures when the user in front of the screen is an authenticated user. So basically we do not know anything about the user is issuing a request, we do not have any way to identify the user, and we have a failure at the server level. So the server, the handler handling the message is failing. And I'd say that the answer is basically lies into using the message ID or a wider concept that we can call the conversation or correlation ID, basically saying since we can define at the queue level the ID of the message, the sender of the message knows what message is just sent out. So it's basically waiting, or can wait, as Elton described, for a reply back from the server saying this message has failed or this message has succeeded. And in this way we can correlate back to a specific session, for example, not speaking about the user in Java, without even knowing anything about the user that is actually connected to the application that we are using. Any comments to add, Elton?
No, that's exactly what I was going to say with the notion of a correlation and a set of messages that belong together. So if you control sending a message to a queue, then you can impose your own ID. So you can have your own message IDs that go through, which is what I do in the demo, which you can have a play around with yourself. And some frameworks do that for you. So you'll get a unique ID for a WebSphere message or an MSMQ message, and then you can work out where that came from.
Okay, great. So I'd say that we have time for the last question. That is, what are pros and cons of having message handlers as Windows service versus WCF service? If I understood the question correctly, is asynchronous versus synchronous calls.
Yeah, absolutely. The notion of a Windows service that sits there and looks at a queue and deals with messages when they come in, as opposed to a WCF service where you, or any kind of synchronous communication where you deal with messages, deal with requests as you receive them, direct communication with the client. It's about decoupling. So some of the pros are we've been kind of walking through with these webinars. The first one that I was involved in is about scale. So if you've got a queue, then sending a message to a queue is a cheap operation. So you can have lots and lots of, say, web servers sending messages to a queue, and you'll get a response very quickly. And pulling messages from a queue is something that any number of handlers can do. So you can scale up and down as you need to very easily. And while you're doing that scaling, the messages that are in flight that are waiting to be dealt with are sat in the queue in the order that you receive them. So if I'm dealing with 10,000 messages per second, and I suddenly find that I'm not getting through the queue's getting bigger and bigger, then I can trigger some more handlers, and then I can double the amount of capacity that I've got and bring that queue down to size. And similarly, when the queue is having a low capacity, so there aren't very many messages coming through, I can scale down. And there are, once you bring this whole thing into the cloud, which we're not necessarily the focus of these webinars, but if you were to have, rather than a Windows service, if you were to have an Azure cloud service listening to a queue, and you were to use an Azure queue, then you can automate that whole scale thing. So you can say, if the queue's got more than 1,000 messages waiting, then fire up another handler from my cloud service. And if the queue's running light, then I can scale down to a couple of machines. So scale is one of them. Being able to deal with failures in the way that we've seen today is another one. So by decoupling whatever your front end is with whatever you're trying to communicate with in the back end, it gives you a lot more leeway to deal with problems in an effective way. And one of the things that we haven't really focused on is messaging lets you have guarantees that you can't have with synchronous communication necessarily. So if I send a message into to a WCF service and or a REST API, and I don't get a response back, I don't know what's happened. I could be sat there for 30 seconds, whatever my client timeout is. The client then decides that I'm not going to wait anymore, and I don't know what's happened. If I've got a business process which requires that message gets through end to end, and even more complex requirements like I've got to have only a message must only be processed once. It's really hard to do that in a distributed system where you're using synchronous communication. But with a message queue in the middle, a lot of the message queues give you that guarantee. You have to use them correctly, but you can have that guarantee that says messages will be processed in order and only once. And so what happens then is when your client sends the message into the queue, as long as it gets a response from the queue saying, yes, I've got your message, you can be confident that it will ultimately be processed in the way that it needs to be processed. So you get reliability, you get the whole option of being able to scale up and down, deal with failures more gracefully, and get a good view of what's happening. So that's there's an option for introspection, because you can look at what's happening in your queues. You can see how busy they all are. So typically you'll have lots of different message types. Depending on how you're handling it, you might have one queue per message type, and you can see where the load is in your solution. You can see what's happening where, and that gives you a lot of high-level visibility that you wouldn't have using synchronous communication everywhere, because there is no central point where you can look at and say how many how many messages how many messages am I dealing with, because I've got 10 servers somewhere. They've all got a different amount of load. In order to do that, each one would have to post somewhere saying I'm just about to handle a request, or I've just finished a request. So you get a whole load of value-added stuff with message queues. I'm going to stop now because I'm going to cough again. So
thank you very much. So thank you very much for your time, Elton, and thanks for delivering once again that amazing webinar about messaging. And let me remind to all our attendees that they welcome to join us on September the 1st on the next webinar, where we will show how an service bus and the particular platform will make handling failures in a message-based system even easier than what we saw today. So thanks everyone again for your time, and see you next time. Bye.
Bye-bye, everyone.